Welcome back to our YouTube channel Achieving Artificial General Intelligence, AGI, which is an AI capable of understanding, learning, and performing any intellectual task that a human can, is one of the most ambitious goals in artificial intelligence research. While recent advances in machine learning have been impressive, we're still far from creating systems that can match human intelligence's versatility and adaptability. Below, I'll discuss where AI stands today, the primary challenges in achieving AGI, the methods being explored, and some perspectives on when or if AGI might be reached. 1. Current state of artificial intelligence. Most of today's AI systems are classified as narrow or weak AI, meaning they are highly specialized for specific tasks. For example, GPT-4 can generate human-like text but lacks true understanding, common sense reasoning, or autonomous goals. AlphaGo mastered the complex game of Go, but its expertise doesn't transfer to other tasks. Self-driving car systems can navigate roads and respond to specific inputs but don't generalize to unrelated domains. These examples highlight the significant progress in narrow AI while underscoring a critical limitation: these systems lack the cognitive flexibility and reasoning abilities of human intelligence. They excel in specific, well-defined tasks, but fail to adapt to tasks outside their programming. 2. What AGI would need and why it's challenging to reach AGI. AI would need to exhibit a broad range of capabilities, some of which are currently well beyond the reach of today's models: general reasoning and common sense. Human intelligence includes extensive common sense knowledge that allows us to understand and navigate everyday situations. Capturing this type of reasoning in AI is difficult because it often relies on implicit understanding, which is challenging to encode in machine learning models. Flexible transfer learning. AGI would need to learn skills in one context and apply them to new, unfamiliar ones. This ability, called transfer learning, is currently limited in AI, which often struggles to generalize knowledge across domains. Self-awareness and intentionality. AGI would need some level of self-awareness to make autonomous decisions, recognize its own goals, and adapt. The concept of machine self-awareness is complex, both technically and philosophically, and goes far beyond current technology. Minimal supervision learning. Humans learn a great deal through exploration and interaction with the world, without needing constant guidance. Most AI systems, by contrast, depend heavily on large, labeled datasets and explicit programming. For AGI to mimic human learning, it would need to learn through minimal supervision or in a self-directed way. Social and emotional intelligence. Human interactions often rely on social cues, emotional intelligence, and empathy. To operate in human environments, AGI may need to interpret emotions and respond appropriately, an area where current AI systems struggle. 3. Technical challenges in building AGI. Several significant technical challenges stand in the way of achieving AGI: memory and long-term context. Human intelligence relies on long-term memory and context, which allows us to build on past experiences and maintain continuity in complex tasks. Current AI models typically have limited memory and struggle to maintain or recall long-term context. Computational and data demands. Training advanced models requires enormous computational resources and data. AGI would require even greater computational efficiency and access to diverse types of data to operate effectively in varied scenarios. Architectural constraints. Current AI architectures, such as deep learning neural networks, excel in narrow domains but may lack the flexibility needed for general intelligence. Achieving AGI may require new architectures or hybrid systems that combine deep learning with symbolic reasoning. Safety and alignment. As AI capabilities grow, so do the risks associated with ensuring that an AGI's goals align with human values. Ensuring that AGI systems act in ethically responsible ways is essential to avoid unintended or dangerous outcomes. 4. Philosophical and ethical questions. The pursuit of AGI brings up profound philosophical and ethical considerations. Defining intelligence. Intelligence itself is complex and multifaceted. Defining what general intelligence means for machines is challenging. Without a clear definition, it's hard to set specific benchmarks or goals for AGI. Consciousness and moral rights. If AGI systems were to achieve a form of consciousness or self-awareness, it might necessitate rethinking moral rights and personhood. If AGI systems become sentient, should they be granted some form of rights? This question is complex and unresolved. Potential for misuse and control. AGI could be an incredibly powerful tool, capable of both positive and negative impacts. It's critical to establish ethical guidelines and regulatory frameworks to prevent misuse, though doing so on a global scale is challenging. Human identity and economic impact. If AGI can perform most human jobs, this could lead to widespread economic and social upheaval. Questions about the future of work, the role of human intelligence, and economic inequality would need to be addressed. 5. Approaches and research directions. In AGI, researchers are exploring multiple approaches to overcome the limitations of narrow AI and move closer to AGI. Some of the leading methods include multi-agent systems and embodied AI. Some researchers believe that placing AI in real or simulated environments where they interact with other agents may help develop generalized intelligence. Embodied AI, or AI in physical robots, may encourage learning through interaction and real-world feedback. Hybrid models, combining deep learning with symbolic reasoning, may help overcome some of the limitations of purely neural network-based models. Hybrid models aim to incorporate aspects of human reasoning and structured knowledge into AI, potentially making it more flexible and generalizable. Self-supervised learning. Self-supervised learning allows AI to learn from unlabeled data, enabling it to acquire broader and more adaptable knowledge. This approach has shown promise in language models, and further development could make AI systems more versatile. Neuroscience-inspired models. Some researchers look to the human brain for inspiration, hoping to replicate aspects of human cognition. While we're far from understanding the brain fully, this approach may yield insights that lead to more robust and adaptive AI architectures. 6. Timelines and predictions. When it comes to estimating when AGI might be achieved, there is little consensus. Predictions range from a few decades to over a century, depending on the perspective. Optimistic estimates. Proponents such as Ray Kurzweil suggest AGI could be achieved by the 2040s, citing exponential advancements in computing power and AI algorithms. They argue that breakthroughs in areas like neural networks and computational efficiency could make AGI possible within the next few decades. Skeptical perspectives. Many experts caution that achieving AGI may require a deeper understanding of human cognition and consciousness, which remains elusive. Given the current gaps in knowledge, some researchers argue that AGI may remain out of reach for a century or more, or possibly never be achieved. 7. How we might recognize AGI. If AGI were realized, confirming its presence would not be straightforward. Several tests have been proposed to evaluate whether an AI has achieved general intelligence. The Turing test, initially proposed by Alan Turing, this test examines whether an AI can convince a human that it is also human through conversation. However, as recent AI language models have shown, passing this test alone may not indicate true intelligence. Broad benchmarking. Testing AGI across a wide range of tasks, including language, physical manipulation, social skills, and emotional reasoning, could help assess its generality. True AGI would need to perform well in various domains, not just specific tasks. Self-awareness and theory of mind. Since AGI would ideally have some level of self-awareness, it could be evaluated based on its understanding of itself and others. For instance, can the AI recognize itself in a mirror? Can it infer the intentions of others? 8. Conclusion. Are we close to AGI? In summary, while AI has made impressive advances in recent years, AGI remains a distant goal. Current AI is limited to narrow domains, lacking the flexibility, common sense reasoning, and autonomous learning that characterize human intelligence. Building AGI would require overcoming substantial technical, philosophical, and ethical challenges, from developing new architectures to ensuring safe and ethical deployment. While some researchers believe AGI could emerge within a few decades, others caution that it may require fundamental breakthroughs or could even